Hello everyone. In today's lecture we'll study about differentiability. Okay, so in the previous lecture we have seen continuous function. What is continuity, right? How to tell whether a function is continuous or not. Alright. So today we'll be seeing how to tell whether a function is differentiable or not, and how to differentiate a function, how to find derivative of that function. Okay. Alright, so suppose if we have a real valued function f, and C is a point which is in its domain. Alright, so the derivative of that function at this point C is defined by this. Okay, what's this? Limit h tends to 0, f of C plus h minus f of C whole upon h. Okay, so this is the derivative of that function, of that particular function f at a particular point C, and this point C, it is in the domain of that function f. Alright, okay, so derivative of a function f at C, it is denoted by this sign, f dash C. Okay, f dash of C. My function was f, this function f, and I am finding value of the derivative of this function at this point C. Okay, so the derivative of that function at point C is defined by it's denoted by this f dash C. Okay, or you can write it like this also, d by dx of fx at C, at this point C. Okay, if I just write this d by dx of fx, so that means I am finding derivative of this function fx. Okay, but no particular point is given. But if I write like this C, so that means I am finding derivative of this function at a particular point C. Okay, alright, so in general we can write it like this, f dash x, that means derivative of a function with respect to x. How to derivate it, how to find differentiation of it? Limit h tends to 0, f of x plus h minus f of x upon h. Okay, alright, now we'll see algebra of derivatives. It's quite simple. Like if we are adding or subtracting two functions, we have two functions u and v. If we are adding them or subtracting them, okay, and then we have to find derivative of this combined function. After adding these two, whatever we'll get, we have to find derivative of that, or after subtracting these two u and v, whatever comes, we have to find derivative of that. So how to find derivative of it? What you can do is you can find derivative of first function plus or minus derivative of second function. You can see over here, u dash plus minus whatever sign is there, plus minus, and v dash, that means differentiation of first function plus minus differentiation of second function. Okay, next, if those two are getting multiplied, u into v, okay, now if you have to find derivative of this combined function, now you cannot do like this, u dash into v dash. No, in this case we'll use product rule. Okay, now what is product rule? Product rule, like this is your product rule, u dash v plus u v dash, that means first you will derive the first function multiplied by second function plus first function into differentiation of second function. Okay, so this is your product rule. Okay, now if those two are getting divided, u upon v, we have to find derivative of this whole thing, u upon v dash. So how to find differentiation of it? You can write it like this, u dash into v minus u into v dash whole upon v square. Okay, so that means first we will differentiate the numerator multiplied by denominator minus numerator into differentiation of denominator, okay, upon the square of the denominator. Okay, so this is what, this is your quotient rule. Alright, okay, now we'll see how to differentiate functions. Okay, we'll take few examples, and through examples we'll see how to differentiate. Okay, so if we have a composite function, like I have taken one example over here, fx. So now I have a function of x. Okay, so you can see function is this, 2x plus 1 whole cube. Alright, so I have to find cube of this whole thing. differentiation of cube of this thing. Okay, so this is your sign of differentiation, d by dx. D by dx means differentiation of whatever I'll write it. Okay, differentiation of this with respect to this x. Okay, now I can find differentiation of a function with respect to a particular variable, so that function should contain that variable. Okay, so I'll differentiate this thing with respect to x only. All right. Okay, so differentiation of this function with respect to x. So now if I'm finding derivative of this function, I am writing d by dx on left hand side, so I have to write it on right hand side also, d by dx of this whole thing. Okay, now to solve this thing you should know a few formulas. Okay, few formulas of differentiation. Now if you want you can download those formulas from Google also, and I'll be sharing that particular sheet with you also. Okay, so just Google all the formulas of differentiation. Okay, because in like while solving these things we should know the formulas, then only we can differentiate these things. Okay, all right, so we'll see. Now look, 2x plus 1 whole cube. 2x plus 1 whole cube is what? You will use that formula, a plus b whole cube, so a cube. Okay, right, so 8x cube, then 3a square, b plus ab square, 3ab square, right? So we'll get this whole thing plus b cube. All right, so this is nothing but what I have done is I have expanded this thing using a plus b whole cube. All right, so you'll get this thing. Now what I have to do is I have to find differentiation of this whole function. All right, now if you see the algebra of derivatives, if we have two or more functions and they are getting added up, so what we can do is we can find derivatives of each of these functions and then we can add them, right, using this first law. You can see over here, if two functions are getting added up, what you can do is you can find derivative of individually, like individual functions, u dash, v dash, and then you can add or subtract them, right? Okay, so what we'll do is first of all we'll do derivative. We'll do derivative of this function 8x cube. Okay, so what you'll get is like in this case we'll use that formula, differentiation of x to the power n. So differentiation of x to the power n is n into x to the power n minus 1. Okay, you can look these formulas in Google also. Okay, so x to the power n is what? N into x to the power n minus 1. Okay, so if we use that formula over here, what we'll get is 3x square. Differentiation of this thing x cube is 3x square. Now 8 is constant, right? So you cannot find differentiation of this thing. Differentiation of 8 is 0. Okay, in fact if you use product rule in this, okay, if you use product rule in this using this formula, then if you find derivative of this, ultimately you'll get this only, 24x square. So what we do is we just take out the constant outside the sign of differentiation. Okay, so if we want to find differentiation of 8x cube, what will come? 8 into 3x square. Okay, 8 into 3x square, because in this you will use that formula, n into x to the power n minus 1. Okay, so you'll get 24x square. Similarly, if you differentiate these functions, what you'll get is differentiation of this 12x square is 24x, differentiation of 6x is 6, and differentiation of 1 is 0. So I have not written 0 over here. Okay, so what are we getting? 24x square plus 24x plus 6. After differentiating this, we are getting this. Okay, so now after this, if you take 6 commons, you'll get what? 4x square plus 4x plus 1. So that is nothing but 2x plus 1 whole square. Okay, so this is how you will find differentiation of a function. Okay, now we'll see some rule. Okay, first is your chain rule. Okay, chain rule means, now suppose if we have function f, a real value function f, and that function is it is comprising two more functions, u and v. Okay, so that you can see u is, like again, u is a function of x, your function f is function of u and v, and u is a function of x. Okay, now suppose if I ask you to find derivative of this function with respect to x, you can see in this function f we don't have any x, right? So if we want to find derivative of this function with respect to x, so what we can do is, look, we can use chain rule in this. How? df upon dx, that means differentiation of f with respect to x is equals to dv by dt into dt by dx. That means what I have done is I have differentiated this function v with respect to t multiplied by this function t, derivative of this function t with respect to x. Now you can see dt will get cancelled, so ultimately what you'll get is dv by dx, and dv by dx is nothing but df by dx only. Okay. Alright, so I'll explain you this thing using one example. Okay, now see, this thing is given, fx is equals to sin x square. Alright, so now we can see in this function we have two functions, one trigonometric function and one algebraic function, right? Okay, so if we consider this thing x square as t, okay, we are taking this x square as t, so my function will become this sin t, right? So this is fx is what, a function of, this is actually a function of t, this function f is a function of t, you can see. So I can write it like this, vt, so fx and vt both are actually same only. Okay, alright, so now what I'll do is I'll differentiate this function with respect to t. So if I find derivative of this with respect to t, dv by dt, so that means derivative of sin t. So differentiation of sin is cos, right? So sin t, differentiation of v with respect to t will give you cos t. And if you differentiate t with respect to x, t, if I differentiate this thing with respect to x, so what I'll get is differentiation of x square is 2x, right? So dt by dx is equals to 2x. I'll get this. Alright, now you can see if we multiply these two, so what will happen? We'll get dv by dt into dt by dx is what? It will give you dv by dx only, and dv by dx is nothing but df by dx only, right? So dv by dt, that means cos t, dt by dx, that means 2x, so cos t into 2x. Now we'll put the value of t over here, so we'll get cos x square into 2x, so that means differentiation of that function is 2x into cos x square. Alright, so this is how you can use chain rule. Alright, okay, so now we'll see how to differentiate implicit functions. Okay, so first of all, what are implicit functions? Like till now the functions were given directly, okay, like this function is given like this, and we just have to differentiate it. But in case of implicit function, one equation will be given, okay, and then you will be asked to find derivative of a particular function. Okay, like for example, this question is given, find dy by dx, that means differentiation of y with respect to x, if y plus sin y is equals to cos x. Okay, so now you can see one equation is given, and then we have to find differentiation of y with respect to x. Okay, in this equation you can see y is over here, and then this term also y is there. Okay, okay, so now what we'll do is we'll differentiate this whole thing with respect to x. Why with respect to x? Because we had to find differentiation of y with respect to x. Okay, so we'll differentiate this whole thing with respect to x. So this will become dy by dx, this d by dx of sin y, then d by dx of cos x. Okay, alright, so differentiation of sin y will give me cos y, then into dy by dx. Okay, why into dy by dx? Because I'm differentiating this term with respect to x, not with respect to y. If I am differentiating this thing with respect to y, so I'll get cos y only, I'll not get this term. But since I am differentiating this with respect to x, so I'll get this extra term. Okay, this will also come dy by dx. Okay, then differentiation of cos x is minus sin x. Okay, now from these two, if I take dy by dx common, so what I'll get is 1 plus cos y is equals to minus sin x. So that's so my dy by dx is what? Minus sin x upon 1 plus cos y. Okay, so this is how you will differentiate implicit functions. Okay, next is differentiation of inverse trigonometric functions. Okay, so we'll be using substitution over here. Okay, look, if suppose this is given, fx is what? Tan inverse x. We have to find differentiation of this function with respect to x. I have taken this is equals to y. Alright, so that means what we have to do is we have to find dy by dx. Alright, and this is given tan inverse x. What is y? Y is tan inverse x. Okay, alright, so I have taken tan inverse x equals to y, so that means x is tan y, right? If y is equals to tan inverse x, so that means x is what? Tan y, right? Now if I differentiate this equation, with respect to x, so differentiation of x is what? 1, and differentiation of tan y is sec square y. Okay, again I'm using formula over here, right? So you have to find those formulas from Google. Okay, then differentiation of tan y is what? Sec square y. Then since I am differentiating this equation with respect to x and this does not contain x, so I'll get one extra term. I'll get this term also, dy by dx. Okay, so 1 equals to sec square y into dy by dx. So that means dy by dx is equals to what? 1 upon sec square y, right? So now you can see I got my differentiation of y with respect to x, but this is not your final answer. Why? Because in my answer I have y, but originally in my question y was not there, right? So I cannot leave my answer over here. I have to substitute this thing. I have to find out value of y over here, and then I have to substitute it over here. So first of all, look, sec square y. How can I write sec square y? I can write it like this: 1 plus tan square y, right? Okay, now in place of y I'll put the value tan inverse x, right? Because I took y equals to tan inverse x, so I'll put value of y, that is tan inverse x over here. So what I'll get is 1 plus tan of tan inverse x and square, right? So tan of tan inverse x is what? X only, right? So what I'll get is 1 plus x square. So 1 plus x square. So differentiation of y is equals to what? 1 upon 1 plus x square. Similarly, you can find differentiation of other inverse functions also. Like for example, you can find differentiation of sec inverse x, sin inverse x, cos inverse x. Okay, all right. Next is differentiation of logarithmic functions. Okay, so now how to use log while differentiating. So look, how will you figure out when to use logarithmic differentiation? Like for example, if this is given, so wherever powers are given, you'll use logarithmic differentiation. Okay, so for this section you should know a few formulas of log, which are like for example, like if you are finding log of multiplication of two functions, so that is equals to log of first function plus log of second function. If you want to find log of division of two functions, suppose you have to find log of a upon b, so that is equals to what? Log a minus log b. Okay, so these formulas, you can look these formulas in Google also. You can Google those formulas. Okay, alright. So now suppose if this function is given y is equals to this. Alright, now what I'll do is I'll take log on both sides. Okay, so if I take log on this side, I'll get log y. Now if I take log on this side, so this is what? This whole thing, whatever is written inside this root sign, this to the power 1 upon 2, the power of this thing, whatever is written, this function, power of this is 1 upon 2, right? So log of, I'll write one thing over here, one formula, log of a to the power b is b log a. Okay, so if you use this formula over here, what you'll get is that 1 upon 2 will come in front. You'll get this 1 upon 2 multiplied by log of this whole thing. Okay, log of this whole thing. Now in this again you will use that formula which I told you just now. These two are getting multiplied and this divided by this. Okay, so we'll use product and division both over here. Okay, so since these two are getting multiplied, so in this we'll use log a plus log b, log m plus log n, right? So we'll get log of x minus 3 plus log of x square plus 4. Alright, then this is in the denominator, this is getting divided, right? So I'll get minus sign, minus log of whatever is there in the denominator. Okay, this. Alright, now if I differentiate this whole equation with respect to x, so what I'll get is, look, differentiation of log y, differentiation of log x is what? 1 upon x. Okay, so therefore differentiation of log y is what? 1 upon y, and since I am differentiating this thing with respect to x, so I'll get this extra term dy by dx. Okay, equals to 1 upon 2. Now if I want to differentiate this thing, so again I'll use that formula, log x, differentiation of log x is what? 1 upon x. So differentiation of log x minus 3 is what? 1 upon x minus 3. Okay, now differentiation of this is what? Now you might say it's 1 upon x square plus 4, but that is wrong. It is not 1 upon x square plus 4, it is 2x upon x square plus 4. Now you might be wondering how come we are getting this 2x. Okay, so in this case you'll use substitution also. Alright, if you want you can find differentiation of this and your of also. So if I take x square as t, so this will become log t plus 4. So again we'll use chain rule also over here. So I'll get 1 upon t plus 4 into dt by dx. So that means I'll differentiate this function also. In this case I was getting 1 only. I wrote 1 upon x minus 3. Why? Because differentiation of x is 1. So directly I have written 1 upon x minus 3, right? In this case I have written 2x also. Why? Because the differentiation of x square is 2x. Okay, so I'll get 2x upon this x square plus 4. Similarly, if we differentiate this thing, log of this, so we'll use that formula, differentiation of log x, that is 1 upon x, right? So differentiation of log of this is 1 upon this. Now we'll differentiate whatever is inside this bracket also, right? So we'll get differentiation of this, that is 6x plus 4. Okay, now what you'll do is you'll take this y on this side, so we'll get dy by dx is equals to y upon 2 into this whole thing. Okay, now I have left my answer till here only, but you should solve it further. How to solve it further? Just put this value of y. What is value of y? This thing. Just put this value over here, then you'll get your final answer. Okay, alright, next is parametric functions. Okay, so now how to find differentiation of parametric functions. Okay, if a function is in parametric form, then how to find differentiation of that? Now what is parametric form? Like for example, if x is a cos theta, y is a sin theta. Now you can see x and y, they don't have like any thing in common other than theta, right? So if I say find dy by dx, so you cannot use this function only. You have to use this function also to find differentiation of x, y with respect to x. Okay, why? Because this function, it does not contain any x, right? This function does not contain any y. So how to find dy by dx or dx by dy? So you have to combine these two functions. Now how to combine these two functions? If we find differentiation of this function with respect to theta, why with respect to theta? Because this function, this x is actually, it is a function of theta. This a is constant. Okay, a is constant. So this function x is actually, it is a function of theta. Y is also a function of theta. So what I'll do is I'll find differentiation of x with respect to theta. So I'll get minus a sin theta, right? Why? Because cos theta, differentiation of cos theta is minus sin theta. and dy by d theta, that means differentiation of this thing with respect to theta will give me a cos theta. Why? Because sin theta, differentiation of sin theta is a cos theta. Now if I divide these two, I want to find dy by dx, right? So how to find dy by dx? If I divide this and this, so what will happen? Dy by d theta divided by dx by d theta. So d theta will get cancelled, right? So we'll get dy by dx only. Okay, so dy by d theta is what? It is a cos theta, and dx by d theta is minus a sin theta. So I'll get a cos theta upon minus a sin theta equals to minus, it is equals to what? Minus cot theta, because a will get cancelled, we will get cos upon sin. Okay, so we'll get minus cot theta. So this is how you will differentiate a function which is in parametric form. So I'll leave it till here only. Hope you guys understood whatever is told in this lecture. Still, if you have any doubt in this lecture, so you can leave a comment and please let me know. Okay, thank you so much for watching.